Hi, I'm Maddie, and this is Juan Guillermo, and in this presentation we're going to be answering the question of, can all data be modeled by a known mathematical function? We're going to consider the reliability and the validity of mathematical models in describing real-life phenomena.
Okay, so firstly, it's important to say we are going to explore this question through certain areas of knowledge such as math, art, philosophy, which is a discipline within the human sciences, and natural sciences such as chemistry or physics. So it is important. We're going to use these areas in order to demonstrate that, in our perspective, mathematics, despite being able to accurately, or to a certain extent, accurately represent or approximate certain elements of reality, it fails to actually portray the real values or the nature values as a certain. So we're going to start with economics. Economics is a discipline within the human sciences, and it is possible to say that, for instance, in models such as profit models, enterprise models, or the the economy itself as a from a macroeconomics standpoint, mathematics is really useful in order to make predictions or to exemplify elements of reality. For instance, by calculating the area below the curve, it is possible to predict elements such as profits, losses, and act according to this. Nonetheless, the fact that there are several random errors and several variables that can't be taken into account, such as, for example, human factors, it makes it impossible to actually portray a completely accurate model of reality. So it's only an approximation.
Now, contrast to economics, art is much more abstract. Now, also psychology, because the fact is that in theory and in practice, it's very hard to model human emotion, which is what psychology and often art is based upon. Human emotion can only be guessed upon, it can't be predicted. Now, mathematics could be used to model if humans were predictable, if you could model their thought patterns, but truth is that you can't, which makes them, which in terms of math, which makes them hard to model.
Also, it is possible to say that in areas such as the ones my friend Addy is talking about, certain elements are not quantifiable, such as as Addy said, the emotions, which, although through certain other models which approximate reality, such as statistics, which allow us to predict certain characteristics or behavioral characteristics, the quantifiable parts of the human being cannot be expressed as a mathematical model. So in this sense, although reality can be approximated and can be further understood through mathematical models, it fails to actually portray reality as it is. For instance, taking into account models which use mathematical theories, such as the models of ideal gases or the atomic models, which are used in both physics and chemistry. Mathematics is used to approximate certain elements of reality. For instance, in the model of ideal gases, it is used in order to mathematically predict the reaction of certain gases within certain conditions and variables. Nonetheless, the fact that the variables within nature are thousands or even millions, which can't be all quantified or measured, mean that this model does not accurately represent reality, but only approximates reality. Nonetheless, for instance, certain engineerings or other disciplines use this type of model in order to fairly deduce certain outcomes and use this for specific targeted uses. For instance, planes which use the resistance of air, although not calculating all the variables in order to assure that the plane is going to stay in the air and not crash. These models, despite not accurately, like to 100% representing reality, to a certain extent, present data reliable enough to base our everyday knowledge upon.
And we must also consider that while art is often difficult to model with mathematics, mathematics is in fact used to describe art as a phenomenon. Now, for example, there is an entire branch of art dedicated to mathematics. This is known as geometric abstract art. An example of this would be the Russian black square, a piece of artwork that includes a geometric number of black squares, all fitted inside a set dimension.
For instance, now talking about more mathematical elements such as calculation of areas or even probability. If we talk, for instance, about calculation of areas, if we use a specified figure, geometric figure such as a circle or a square, it's easy to accurately represent reality. Whereas if we try to, for instance, calculate the area the of the leaves of a tree, although we can make approximations, the fact that it does not have a trend or a specific trend or a value that can be modeled through an equation makes it impossible to actually get an exact value or a value with the desired uncertainty of the area. Whereas, for instance, in probability, we can calculate expected outcomes. For instance, if we roll a dice, nonetheless, as we take into account independent probabilities and other elements, variables within nature, it is impossible to actually predict through 100% accuracy all results. So we then with us conclude that although for mathematics it is possible to actually represent reality through models, these models do not have 100% accuracy. Nonetheless, in certain areas they are useful enough to base our everyday predictions or everyday uses of these models. Thank you.